Welcome to P Coding. This is Babak, and in today's tutorial I am going to talk about some of the fundamentals of probability and random number generation in particular. Imagine that you have a target probability distribution and you are supposed to generate some random numbers, and then you have to accept some of these samples according to that target distribution, and you have to reject the samples that are not actually falling according to that target distribution. So what we should do in today's tutorial, I'm going to go over this concept, so stay tuned for the following. First thing that I'm going to do is to define a target distribution. So far we used to work with several distributions, but one of the easiest ones when we were actually unaware about the target distribution was about using the normal distribution. But let's make that normal distribution a bit complex by truncating this distribution. So I'm going to use the curve, which is actually an inbuilt function, and using the characteristics of the normal distribution, which are the D, P, and Q norm distributions, and they are accords with some x value, as you can see the yellow hint, and you can assign using the mean and standard deviation. However, this zero mean and unit standard deviation accords to the standard normal space, and I'm going to work with somehow more complex probability distribution. So I'm going to use some larger values. Let's, for example, say 3 and the standard deviation of 2. This is going to be like a bit wider distribution, and then I'm going to actually normalize it according to itself. But this time I'm going to assign some quantiles and also the intervals of this probability distribution using the p-norm function, and the value is going to be 1, for example, and let's use the same values as the previous one. So this is going to be alright, but the point is that I'm going to assign it to some interval. So let's see, let's make it from 1 to 10. So this is our target or final probability distribution that we want to generate our samples. As you can see in here, this is actually a truncated or a scoot to the right side, you can say. The next thing is that I want to generate some random numbers, so I have to define a global number of samples. Let's start with 1000 samples, and then we will evaluate the effect of the number of samples on the final results. Then I have to define my random numbers. So let's start with calling this as sample, and using the famous data frame function we can define our samples, but I'm going to propose some samples. Then I'm going to accord these samples according to the target distribution. So let's define this as propose, and then I'm going to use the runIf function, which actually returns some uniform numbers, but this time I don't want actually some uniform numbers. I want to accord my generated numbers with these intervals that I already defined in my target distribution. So this is the first point when we want to define our proposal function. So I'm using the number of random numbers, which actually I already defined, along with these intervals that I already defined in the previous function. So this is my function here. This is actually my function, and then I am going to accord these samples to some value. Let's call this target density. This is actually, so this is my target density in here, and then I am going to use the dnorm again to generate according to the density of this proposal function. So using the density of this proposed function that we already have, so we want to do, this is the next step. previously we generated the random numbers according to the interval. Now I'm going to accord it to the mean and standard deviation that I already defined in the previous one, and then I have to normalize it. It's just the first thing that we already did, exactly as the above. All right. So first, I generated my random numbers in here using the running function and in accordance with the interval of the target distribution. Then I am going to generate them according to the normalization of the and also the truncation that I already did in here. So this is the point that we have to accord everything of our random number generation. So the next step is to do some acceptance or rejection, the samples that are actually proportional to the target density or they are not. So first let's define a threshold or a max density that these samples can be a form of those density. So let's define this as max dense and also using the max inbuilt function. And what I was working with, it was the sample, and I am going to accord it with the target density. So this is the target density, and when we are generating some samples, for example, we have 1000 samples in here, and we are accepting some samples and we are rejecting some samples. The samples that are actually rejected, they are going to be empty valued or not applicable to these samples. So what we should do, we cannot use some values that are not assigned. So I have to remove these non-applicable samples using the na.rm function, which is actually another inbuilt function in R. And you can say yes, you can just make it t, and it will give you the t function in here. And then after assigning this threshold, you can simply define the number of samples which are actually uh, accepted. And let's define this. How we can define this using the if-else function. So let's call this run if, because I am going to generate these numbers, and then I'm going to use the global random numbers, and this is actually because they are either true or not. So I'm going to make it 0 1 dimension, and then I am going to say compare these with the target density with here. But the target density in here, as you can see, I am going to yet again compare it with the max density or the threshold that I already defined in the previous one. And I have to also assign the true false in here in case that the samples are accepted or rejected, so it returns the ni r term in here, and it can finally results the satisfies the criteria. The next point is actually sampling. So let's go over what I did so far. I defined a threshold for my samples, generated samples, according to the target distribution. And then I assign the values that are not in the part to be actually replaced. And then I define the threshold for accepted samples, which are actually not in this previous condition. And then I use the sample target density to actually accord those randomly generated samples with the maximum density of the target distribution. So this time I am going to define my random samples in here. And what should I do? This time I already proposed a series of samples in here. So I have to check these two functions. I have to go over the max density and also assign the number of samples that are actually following that threshold. So I'm going to call this sample and compare it with what? With the proposal function, and then I'm going to use the sample again and see if it is accepted or not. So I'm going to use this, and as you can see, from 1000 samples, almost 460 samples are satisfying this condition in here. So let's see how many of these samples actually almost more than 500 samples are not following this target probability distribution. So they might be like falling out of this truncated PDF. So let's use some graphical representation to see whether they are falling under this curve or not. So let's use the hist function here, and what I'm going to see is actually the number of samples, the 460 that fall in, and then let's make the frequency off, and then let's define some visualization in here, and let's call this color for yellow, and then the number of beans in here, which is actually we can call let's see 100. Okay, as you can see, this is just a histogram of the generated samples, the 460, but actually it gives us in 100 beans cumulative density of this, because we turn off the frequency off. So now I'm going over to again use this curve in here, and let's just copy this. Let's just copy this in here, and this is already enough because we assigned the intervals. All right, and remember to add it to the previous one, and I'm not going to get a new graph, and yet again remember to assign the call, and let's make it this time red. All right, so as you can see, the generated samples or the accepted samples, which actually are 460, are way out of the threshold. So this is actually the first part of our tutorials today, that we generated these samples according to the target distribution. But the point is that the number of accepted samples are not desirable. What we should do is to make the number of samples more. Then we get to the point of convergence of the randomly generated samples, which simply means that you have to increase the number of samples so you can get the desired results. Let's start off by, for example, making 10,000 samples in here, and then let's see that when we increase the number of samples, the shape of the generated samples and the target density are somehow converge or shift to the final results. If we increase the number of samples to, for example, 50,000 samples, we should expect more refinement in the generation. So there is one adequate number of samples, which actually behind that number of samples we don't expect any more of increasing the shape or the satisfaction of both proposal and target density. So this time I'm going to make 100,000 samples, and you can see that after 100,000 samples this is actually adequate, and there is not much of difference. So we can actually make 10,000 more samples in here, And as we can see, we should not expect much more difference. So this is the second point of our today's tutorial, that there is some adequate number of samples that we need when we are generating some samples, and then we can say that our proposal function is actually accords with the target distribution. So thank you for watching for today's tutorial. Let me know if you want to know more about this type of sampling, which actually covers the rejection or acceptance of the number of samples, and actually regards the generated samples to the maximum number of required samples. Thank you for watching. Don't forget to subscribe, and also let me know of your comments and your thoughts. It is really helpful, and I can produce more tutorials in accordance with what you think is most suitable for you. Thank you so much.